Okay, so another fun thing that we can do with shapes, with plane figures and parts of plane figures is we can make a tessellation. And tessellations are a pattern of shapes that are repeated with no gaps or overlaps. So I want to show you some examples of tessellations. Okay, let me get the lighting just right here. There we go. All right, so here is a pattern of, do you know what kind of polygon those are? Those are hexagons, so it's making a pattern of hexagons, and they're not overlapping each other, and there's no gap. You could see that we could easily fit another hexagon right here, okay? So hexagons can make a tessellation. You can see over here, squares can make a tessellation. There are no gaps in between the squares and no overlaps. And we could just continue a row of squares here and a row of squares here and here and here. So the pattern could just keep on going, right? Triangles can make a tessellation. So you can see we could fit these triangles in different ways. If you cover these up, you can see there's the hexagon we made with our triangles just a moment ago. So triangles are a great shape for making a pattern with no gaps or overlaps. Okay, so now I'm going to show you some examples that are not tessellations. So here's circles, okay? Now the circles do not make a tessellation. Do you know why? Right, there are gaps right here, okay? So the circles aren't touching on all the parts because remember a circle is a closed curve. It's not a polygon. It doesn't have any sides. Okay, let's take a look at another one. Okay, so here we have some octagons, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 6, 7, 8. Yeah, octagons. Sorry about that. And the octagons do not make a tessellation either. Here you can see that there is gaps right here, so they're not touching on all the sides. And then here we have some pentagons, and you can see there are gaps here too, so pentagons can't make a tessellation. But the squares and the hexagons and the triangles can do it. Now, a fun thing that people do is they make their own shapes, and they can make really interesting artwork out of it. So I've posted a video. If you feel like you've got some time and you want to do something creative today, you can make your own tessellation patterns with different shapes. So there's a video that's posted today, but it's just optional. You do not have to do it. It's just for fun if you would like to. Okay? All right, so let's go on to our workbook page. I want to do it with you because it's a little bit different than what we've been doing. It's not hard, but I just want to make sure that you are understanding it. Now, boys and girls, it would really help if you have a ruler to make nice straight lines. But if you don't have a ruler, you can use even a Post-it note or block or something like that. I had some Post-it notes. I don't know what happened to them. Okay, so we are going to draw these plane figures, and our book calls it partitioning. So what we're going to do is slice these plane figures up into equal parts of the whole. So we're going to be making fractions. All right. So it says write the name of the plane figure. Okay. So here's our plane figure. Let's count the sides. 1, 2, 3, 4, 5. How many sides does it have? It has 5. And think of a 5-sided polygon. What is that called? I hope you said pentagon. That's what it is. Okay, a pentagon. Okay, so now you can see that they want us to partition in this sort of pattern. So look at the fraction up here. It's 1/5. So we want to make sure that when we're done, we have 5 slices of this pentagon that are the same exact size. Okay, because remember, fractions are equal parts of the whole. So each of our pieces of this pentagon have to be a whole, or have to be equal so that they can make the whole. So here you can see that we have these vertices that we can draw a line straight to the center, and that's going to help us put this pentagon into fifths. So all you have to do is get your straight edge and line up your dots to make those lines, okay? So connect that center dot to the outside vertex, and you're going to draw your pentagon into fifths, okay? And then we would label each of these parts, right? Each of those parts would be 1/5. Okay, so let's go on to the next one. All right, so look at how many sides it has. I want you to count the sides, and I want you to think of the name of this polygon. If it has this many sides, what is that called? Okay, did you count 6 sides? 1, 2, 3, 4, 5, 6. And a 6-sided hexagon, a 6-sided polygon is called a hexagon. So write hex, H-E-X-A-G-O-N. Okay, so now we want to make sure that we're getting this hexagon put into equal parts, and I would like for us to cut this into 6 or partition this into 6. So what you can do is you could, here they gave us a center point in the middle, but they didn't give one here. So here is my suggestion for you. Start here and draw a diagonal line down to this bottom one, and then do the same thing here. So you're making an X right in the middle, okay? So get your straight edge, whatever you're using, a ruler or a book, a notepad, something, okay, to make your straight edge. Okay, do you see how I have an X right in the middle? Now I can see that this piece and this piece, those are equal. But would you say these two shapes are equal? No, they're not, right? These are much bigger than these pieces. So what do we have to do? Can you think? How could we make this into equal sixths? Okay, so right now we have fourths, right? But these are not equal, so we've got to do something with those. So can you see what you should do? I'm guessing that you said that we're going to go from this line, or from that dot to that dot. Let's see if that works. Okay, so now those look very equal, don't they? Okay, so how many equal parts of the whole is there? What would we put for our fraction in each piece? So you've got to think how many pieces all together, and that's your denominator. Okay, so how many pieces are all together? That's right, 6. So we want to have our denominator is 6. And then each one of those parts is just one of the 6, right? So we label each part 1/6. Okay, does yours look like that? Okay, so next we have, I want you to count the sides and figure out what kind of polygon this is. See if you can name it before I say it. So count your sides. Okay, did you count 8 sides? Okay, that's correct. It's 8 sides, and an 8-sided polygon is called, think of an octopus, right? Octopus with 8 legs. It's an octagon. Okay, octagon. All right, now they gave us some points to draw our lines, okay? Now this time we're not going to put it in 8ths. This one we did in 5ths. This one we did in 6ths. Let's draw lines to connect, okay? So let's draw a vertical line first of all between those 2 dots. And then let's draw a horizontal line to connect those dots. And then I want you to tell me Whoops, that didn't look very good. Let me try it again. My parts didn't look quite equal, so let me try a better line. Okay, a little bit better. Okay, so your line should look like that. All right, so how many equal parts do we have? Okay, so you should say 4, right? There are 4 equal parts. 1, 2, 3, 4. And so if there are 4 equal parts, that means our denominator is going to be 4. And then each one of those parts is only 1/4 of this octagon. So it should look like that. Okay, so let's take a look down here. This should be pretty easy. They're showing that this circle was cut into fourths, right? And now we want the same number of equal parts, but we want to do it another way. So this is pretty easy. They gave you the endpoints, and you can draw those lines so that you're still in fourths, but it'll look different, right? So if you connect those dots, go right across the middle with a vertical line and a horizontal line, and look at there. We've got fourths in this circle and fourths in this circle, but they look different. Okay, here is a square, and they've partitioned the square into 3 rectangles, and they want us to do the same thing. We still want to partition the square into thirds, 3 rectangles. Can you see how to do it? Okay, I'm going to go slow, and you think about how you're going to make this square partitioned into thirds, but looking a different way. Okay, the dots are there to help you, so give it a try, and then I'll show you mine. And if you didn't do it right, you can pause it and fix it, okay? All right, so we wanted a square that was still partitioned in the same way. So the square had 3 vertical rectangles, and this time we did 3 horizontal rectangles. So even though the rectangles are going the other way, they're still 1/3 of the same size square. The rectangles are still the same size, so they're equal fractions. They're equivalent fractions, right? Okay, so let's do some more. We're going to partition to show fourths in different ways, okay? In 4 different ways. So they've got a square. They want us to make fourths in all of these different ways. So we're going to draw our lines connecting these dots. Now, what do you think we're going to do? This one's pretty easy, right? If we do a vertical line and a horizontal line, that'll make 4 pieces, won't it? Okay, so let's try that. And does that give you fourths? Remember, 4 fourths makes a whole. Okay, so yes, 1/4, 1/4, 1/4, 1/4. Okay, what do you think about this one? We want to still have this square partitioned into fourths. We want 4 equal parts. 4 equal parts. So you think about what to do, and then I'll show you my answer in just a moment. So you go ahead and draw it out on yours. Let's see what you came up with. Okay, so we want still fourths. We want our square partitioned into 4 equal parts. So did you do this? Okay, so even though the triangles are facing different ways, they are the same shape. They're the same shape, same size. Okay, so this is 1/4 of the square, and this is 1/4 of the square, even though they are different shapes. Okay? All right, how about this one? What do you think you're going to do to make 4 equal parts of this square? Partition it into 4 equal parts. Think about what you're going to do, and then you can check yours against mine in just a moment. We want 4 equal parts. We want that square into fourths. All right, did you have 4 rectangles just like me? Okay, great. So this square is cut into fourths. This square is cut into fourths. This square is cut into fourths. Wow, look at this one. What do you think we're going to do? We want this one to be fourths as well. So what do you think we'll do? Okay, I see there's just one dot at the top and 3 at the bottom. So play around with that. See what you can come up with, because we want to have 4 pieces, but we want all the pieces to be the same shape and the same size. Now the shapes don't have to be going the same direction, but we want them to be the same shape and the same size. Okay, let's see what you came up with. All right, here's what I came up with. All right, this time we took the square and I drew a line here and one here and one here. And look at, I've got 4 different types of triangles. Here we had 4 triangles, but here they're different shapes, okay? These were more regular and these are irregular triangles. But still, each of these pieces are exactly the same size and the same shape, okay? So we just did our 4 squares into fourths in 4 different ways. So let's answer those questions, okay? So the first one, are the 4 figures all the same size and shape? So are our squares the same size and shape? Yes, the squares that we started with were all the same size and shape, so that would be a yes, okay? And then number 8 says each figure is partitioned into fourths. Are the fourths in each figure all the same size and shape? So what that means is, are these pieces all the same shape? Are all these pieces all the same size and shape? Are all these pieces all the same size and shape? And are all of these the same size and shape? Yes. Now these are not the same as these, but we're talking about within each square, are the pieces the same size and shape? So that would be yes. Now look at this last question here. Are all 16 fourths, okay, because we have 4 fourths, right? And 4 fourths would be 16 fourths. Are they all the same shape? Well, that's an easy no. This is not the same as this. These shapes are not the same as these shapes, right? So not all of my 16 fourths are the same size and shape. So that would be a no. Okay, so let's move on to the back, okay? And these I would like for you to try on your own, okay? And I'm going to post a picture of the answers on the back so that you can grade it yourself, okay? So you're going to just do the same thing. You're going to read really carefully, okay? It says write the name of the plane figure, so you're going to write the name of this figure. What's it called? What is it called? What's this one called? Write it down, all right? Write the name of the plane figure and then partition to show the equal parts, and then label each part. So you're going to use those dots that they're using you. You're going to use those dots that they're giving you to draw the equal parts, right? And then you're going to label them just as we did on the front. You're going to give them a fraction label, okay? So you'll count how many parts all together, and then you'll label them, okay? All right, so then second part, you're going to partition to show the same number of equal parts, but in a different way. So this is just like the front two, okay? So we have 2 halves. I want you to make 2 halves on this one in a different way. Here we have 3/3. I want you to make 3/3 on this one in a different way, okay? And then you're going to partition to show 6, okay? So remember on the front, we were showing fourths with the squares. Now you're going to do the same thing, but this time we're making 6 in 3 different ways instead of fourths. Okay, then check your division really carefully. And so do all of this and then check your answers. You do not need to send a photo of your page today, okay? All right, so if you have time today and you feel like doing a little art, you can also check the video on making a tessellation design. Okay, see you later.